This presentation deals with hot work at the WPCF. Hot work on the plant will be completed in accordance with the FM Global Hot Work Permit, subject to continuous gas monitoring, and prohibited inside the red boundary. Definitions. Red boundary is an area encompassing the gas system plus 10 feet, designated by a red line. Continuous gas monitoring. Non-stop surveillance of the ambient air for the explosive limits for methane and hydrogen sulfide. Hot work. Work involving open flames or producing heat and/or sparks. Speaking of flammable materials, it is important to know that we have a system here on site that produces, scrubs, compresses, and utilizes digester gas. It is highly flammable and must always be taken into consideration while working on the plant. We have implemented a red boundary to indicate areas that make up the gas system.
Digester gas is expected to be found in the gas system. However, we have discovered that flammable gas can be found in other areas that contain water and organic material. The following 3 stories are a hot work cautionary tale.
Tomahawk, Wisconsin. 3 workers were killed in an explosion at a manufacturing facility while they were welding on a temporary metal clamp to stabilize a damaged flange connection. The flange was located on top of an 80-foot tall storage tank that contained recycled water and fiber waste. Facility personnel were unaware of the potential presence of flammable gas from the decomposition of the organic material in the tank, and combustible gas monitoring was not typically required or performed prior to starting work. The CSB analysis of the tank contents determined that anaerobic bacteria had multiplied inside the tank and water recycle system over time, feeding on organic waste material. The bacteria likely produced hydrogen, a highly flammable gas, which ignited during the welding. The CSB found at the time of the incident, supervisors and workers were unaware of the risk of flammable gas production from anaerobic bacteria growth. Moss Point, Mississippi, where a tank explosion on July 28, 2014, killed a contract worker and severely injured another. Inspectors found that the incident occurred during hot work on or near a tank containing 8 inches of a slurry of water and fish matter known as stick water. The explosion blew the lid off the 30-foot high tank, fatally injuring a contract worker who was on top of the tank. A second contract worker on the tank was severely injured. Chemical Safety Board investigators commissioned laboratory testing of the stick water and found telltale signs of microbial activity in the samples, such as the presence of volatile fatty acids in the liquid samples and off-gassing of flammable methane and hydrogen sulfide. The stick water inside the storage tank had been thought to be non-hazardous. No combustible gas testing was done on the contents of the tank before the hot work commenced. Kansas City, Missouri, January 3, 2018. An explosion caused by a buildup of methane gas substantially damaged Kansas City's Blue River wastewater treatment plant. Measurable amounts of methane gas had previously been found inside this building, and a gas-fired heater is the suspected ignition source. Chicago, Illinois, August 30, 2018. A worker's torch set off the explosion that lifted the roof off the far south side treatment plant, sending rubble crashing down onto 10 workers and trapping 2 of them. A crew was working on a large tank inside the building when a torch ignited methane gas, fire officials said. The workers may not have been monitoring the area before the torch was ignited. Personnel were required to wear personal gas monitors in the area, and using a torch in that environment was not supposed to happen. These tragedies underscore the extreme importance of careful hot work planning, hazard evaluation, and procedures for all storage tanks whether or not flammable material is expected to be present. Hot work dangers are not limited to the oil, gas, and chemical sectors, where flammability hazards are commonplace. We came to the realization our business here is organic matter and water. It's everywhere, throughout the plant. It's in pipes, in tanks, and in basins. It's with this benefit of hindsight and hearing the accident scenarios from the Chemical Safety Board that we have decided to be overly cautious with hot work on site. Continuous gas monitoring may seem like a pain, but it certainly beats a catastrophic explosion. Put another way, hot work at the WPCF is kind of a big deal. Sensible precautions. That's all it takes to prevent a hot work fire or explosion. Yet every year, hot work is among the top causes of fires and explosions at industrial facilities. The goal of every hot work program should be to prevent hot work ignition sources from coming into contact with combustible and flammable material. When such a program is conducted properly, hot work incidents can be prevented. Prior to requesting a hot work permit, consider the alternatives. Use a cold work method. Manual hydraulic shears versus saw or torch cutting. Mechanical bolting instead of welding. Screwed or flange pipe versus sweat soldering. A reciprocating saw instead of a radial saw. Mechanical pipe cutting versus torch or radial saw cutting. Another option may be to relocate to a hot work designated area, like a welding shop. As a last resort, you can request a hot work permit. When using a hot work permit, protect the facility by removing or isolating combustible, flammable material from the hot work area, confining hot work ignition sources within the hot work area, protecting the hot work area with automatic and manual fire protection systems and equipment, and supervising the hot work area during work and following work completion. Time to break out that combustible gas meter. Continuous monitoring starts before the hot work begins. Required precautions. Verify the hot work equipment is operable and properly arranged. Also, verify your PPE is serviceable and properly worn. Check that the control valves for the sprinkler system are open. Verify that there are no active or planned fire protection system impairments near the hot work area during the work or during the post-work fire watch and fire monitoring periods. Provide manual firefighting equipment, including supplemental fire extinguishers. These are in addition to those extinguishers attached to the building. Preparing the hot work area. Define the hot work area as 35 feet horizontally from all hot work sites and a minimum of 15 feet above all hot work sites. When performing elevated work or work in drafty environments, consider extending the hot work area horizontally to 50 feet. Remove combustibles from the hot work area. If combustibles are non-movable, isolate materials from ignition sources by shielding or covering them with approved welding blankets or pads. Clean up ignitable liquids, dust, lint, and oily deposits. Identify and isolate potential sources of flammable gas, ignitable liquid, and/or combustible dust and lint that may be released into the hot work area during work. Conducting a job safety analysis may identify sources of these materials and whether the systems need to be just de-energized or additional protection is warranted, such as isolation, drain, and purge. Test the hot work area for flammable vapor and gas prior to work and continuously during the work. Protect or shut down ventilation and conveying systems that may transport combustible material into the hot work area or hot work ignition sources out of the area. Extend the hot work area to the opposite side of a building when openings exist through which hot work may pass, or there's a presence of thermally conductive material that may transfer heat through the structure. This is a big deal. In both cases, combustibles on the other side of the wall may be exposed to the hot work ignition source. What I am saying is, even though your meter reads 0 at the place you're conducting hot work, what is the meter reading on the other side of that wall if the heat may transfer through it? The final step on preparing the hot work area is to identify and safeguard combustible lined equipment, piping, or ductwork within the hot work area that have openings that may allow the ingress of hot work ignition sources. When preparing for hot work on or in equipment, identify and isolate interconnected equipment and piping that contains flammable gas, ignitable liquid, or combustible dust and lint. You should drain ignitable liquid and purge flammable vapor and gas from equipment and interconnected piping. Test equipment and/or piping for flammable vapor or gas prior to work and continuously during the work. Conduct testing even if the equipment does not normally contain these materials, as we are working at a wastewater treatment plant and methane gas could be anywhere. Remove combustible debris, dust, lint, and residues from the equipment and interconnected piping. Also, while we're looking at this picture, clean your dryer vent at home. Dryer lint is the #1 cause of residential fires. Treat hot work on combustible lined equipment, piping, or ductwork as a hot work high-risk operation. Again, consider using alternative cold work methods. Or flood equipment with water or continuously wet down the interior during work and post-work. Identify access ports upstream and downstream of the work site and lay out firefighting hose. Or isolate equipment upstream and downstream of a hot work site using a non-thermally conductive material for a blank. Fire watch and monitor of the hot work area. During work, perform a continuous fire watch over the hot work area. Extend from the start to the end of the work uninterrupted. If needed, the fire watch responsibilities should be passed temporarily or permanently if the initial fire watch needs to leave the area. Ensure hot work ignition sources remain in the defined hot work area. Maintain the required precautions listed on the hot work permit. Notify emergency contacts prior to attempting to extinguish any fire. The fire watch has the responsibility to stop all work if unsafe conditions are identified, and then should contact the permit authorizer. Fire watch must be continuous during the hot work activity. Fire watch will continue for another hour after the hot work is completed. Periodic fire monitoring will continue for 3 hours after the fire watch has ended. Now that we have all the pieces in place, we're ready to issue the hot work permit. The hot work permit is a 2-part form that helps establish the hot work plan prior to the start of work and tracks each step during work and post-work. Part 1 of the hot work permit should be posted in a central visible location within the facility to alert personnel of an active hot work permit. Part 2 of the hot work permit should be hung in the hot work area to be used as a reference for the fire watch, required precautions, emergency contacts, etc., to record completed actions from the hot work plan, like completion times, and act as a warning for bystanders smelling or seeing smoke. Hot work on the plant will be completed in accordance with the FM Global Hot Work Permit, subject to continuous gas monitoring, and prohibited inside the red boundary. In summary, hot work on the plant will be completed in accordance with the FM Global Hot Work Permit. Hot work on the plant will be subject to continuous gas monitoring. hot work on the plant will be prohibited inside the red boundary. The red boundary is an area encompassing the gas system plus 10 feet designated by a red line. Continuous gas monitoring is the nonstop surveillance of the ambient air for the explosive limits for methane and hydrogen sulfide. Hot work is work involving open flames or producing heat and/or sparks. Cold work methods include manual hydraulic shears, mechanical bolting, screwed or flanged pipe, reciprocating saw, mechanical pipe cutting. Fire watch must be continuous during hot work activity. Fire watch will continue for an hour after hot work is completed. Fire monitoring will continue for 3 hours after the fire watch has ended. Do you have a good understanding of hot work at the WPCF? If not, speak to your supervisor. Do you have any suggestions for improving this presentation? If so, notify your training provider. If you have any questions, please contact your training provider.